Through previous videos we attempted to give you a general and big picture on KNIME as an efficient analytic tool in data science. After you become familiar with KNIME Analytics platform, it is time to know how data can be conveyed to KNIME. In this video, we will focus on access to data as initial step for working with it and will introduce various ways of bringing data into KNIME. Then, welcome to Intellacct KNIME Micro Learning courses.
Firstly, let's know more about data. Data as an inevitable element in analysis process is available in various formats and different types. Data type is representative of data attribute that declares what kind of value the data has. Therefore, it has been classified in different ways and from different points of view. Internal and external data, traditional and big data, primary and secondary data, structured and unstructured are some ways to categorize data. One of the most popular ways to divide data in groups is classifying it to qualitative and quantitative data based on measurement scale concept. Quantitative data is specific and objective and can be measured by some tools. Numerical facts such as sale amount, revenue, people's weight or height are some examples of quantitative data. On the other hand, qualitative data is subjective and explanatory and its concept points to qualities and characteristics. It has two subcategories, nominal which indicates the names and is used as a label for separation such as gender, marital status, colors, and etc. Moreover, there is no intrinsic ordering to the categories in this type of data. On the other hand, there are ordinal ones which conveys the concept of levels and there is a clear order between these levels from lowest to highest. Education or customer satisfaction are some examples of ordinal data. Working with ordinal data, you should consider 2 points. First of all, the size of the difference between levels is just conventional and can be inconsistent. Second, sometimes we may assign numbers to the levels. For instance, we can score customer satisfaction from 1 to 5 for low to high respectively. This assignment is a kind of labeling and we cannot perform arithmetic operations on assigned numbers. Quantitative data has some subdivisions as well. Interval and ratio are two subgroups of this category. In intervals the space between numbers is equal and meaningful. For example, if you perform a task in 1 hour and the other in 2 hours, second task takes 1 more hours, and this difference is equal in measuring the time of other tasks. Temperature and time are two examples of that. The distinguishing feature of intervals is that they lack a true zero. In another word, there is no lack of time or temperature. On the other hand, numerical values with true or absolute zero are ratio. For example, $0 is the complete absence of money. Population of a country, total sale, product amount, or distance are all examples of ratio data. As stated, there are diverse data types and consequently various ways of classification of them. In another aspect, integer, double or long that are subdivisions of numeric type, string and Boolean, is another famous way to break down data into smaller groups. Why these type of data matters? This table illustrates the answer of this question. As it is shown, statistical computations or arithmetic operations can be performed or just make sense in specific types. All mentioned kind of data and other types are located and arranged in spreadsheets, databases, APIs, or other platforms and software. Now, let's have a look at data structure and types in KNIME. Generally, data is organized in tables in KNIME. It consists of rows and columns. Moreover, KNIME is able to work with diverse data types. In next section we will see how we can get data from files and bring it into KNIME.
Before going to have access to data, first of all we need to create a workflow. In order to keep our data project well ordered, let's create a workflow group and keep our workflows in this group. To do that, go to File, New Workflow Group and follow the wizard. The other way is to simply right-click on Local and select New Workflow Group and define a name for it. In next step, create a workflow in this folder by following the same process and selecting New Workflow. Additionally, we need to have data. During this and next videos we will use some example data provided by KNIME. You can simply drag or copy the data folder that is in example workflows and paste it into your workflow group. Other dataset samples are provided in public space of KNIME on KNIME Hub, and you can reach to them by simple drag and drop. KNIME can read data from wide range of file formats such as CSV, text, Excel, Word, XML, JSON, images, and etc. It does this process using reader nodes. These nodes are usually in orange color with no input port and are located under I/O category in Node repository. This category contains read, write, generation and file handling nodes. In this video, we will study Table Reader, Excel Reader, CSV Reader, and File Reader as the most common used reader nodes.
Let's start with Table Reader node. This node is dedicated to .table formatted files, that is an internal KNIME format. Therefore, it has maximum performance with regard to speed and size and less configuration setting. But, it is not compatible with other platforms. In order to configure this node, double-click on that, use toolbar configuration icon or right-click and select Configure. In following window, there are some tabs. This configuration interface is almost the same in other reader nodes. The first is Setting tab and helps you to define the path of the file. There are several ways to specify the path of a file. To do that, you need to define an input location that is consisted of 3 parts: type, specifier, and path. Type states the file system type. Local file system acts as an absolute address and defines the direct location of file on your system. While mount point, relative to, and custom URL will guide you to the file with regard to its location in a specific mount point or workflow. By selecting them, specifier box will become active to set out more details, for instance, defining relative address with regard to which location is considered. Just pay attention that based on your file location, some of the predefined items may be deactivated and shown in gray color. Lastly, in file box, you can state the path. Assume we want to read the items.table file from basket folder. We can do it in these ways. 1. Use local file system and find the file location using Browse button or type it directly. At bottom of the window, you can see a preview of file display. 2. Use mount point and then local, that is the mount point the file is located in. In next step you just need to define the path from this point forward. It means you just need to identify the folders and file name. The process is the same if you select relative to and current mount point option. 3. Use relative to and current workflow. In this way, you need to locate the file regarding to your current active workflow. To reach that, we need to go up to the data folder. We can do it by using 2 dots for each level up. 4. Use relative to and current workflow data area. Each workflow has a folder in KNIME workspace. In this folder, usually there is a data subfolder. If it is empty, like here, just create it by transferring data to this folder through copy and paste. Then, you can define the path of your file regard to this data folder. The advantage of this way is that your reader node can be run at any location, if you move or share the workflow, because its folder always moves with data folder inside it. 5. Use custom KNIME URL. Next you just need to define the address of file using KNIME protocol as it is shown. In addition to all mentioned ways to read items.table file, we also can drag and drop it directly to the workflow editor. KNIME usually can guess the structure of the file and will assign the appropriate node to that, as it was indicated. try to use relative path for addressing a file as it automatically updates the mount point, and you can deploy the node in KNIME server or hub and share it without reconfiguring. After setting the path, let's review other parts of Table Reader configuration window. In Mode part, you can define if you are trying to access to one file or multiple files in a folder. This feature helps you to read several files by one reader node and concatenate them in one table. Filter properties let you filter the files based on their extension, name or folder name. It also facilitates the filtering process by providing some more options like being case sensitive or defining the name of files using regular expression. Checking this box let you choose subfolders as well. In Next part, you can identify the way of assigning row IDs. As you see in Preview section, each row is defined with the row ID and each column has a header. In Row Handling section, you can specify how the row be displayed. In Preview, a quick display of data is illustrated. The letters in headers indicates the supported data types in KNIME, D for double, I for integer, S for string. As you see, generally the data structure in KNIME is tabular, and then we can refer to these types as column types. Other supported types are diverse, and the most common of them are long, Boolean, date and time, and unknown types. The last one will be shown by question mark. If you right-click on header, you can see some available renders. For example, for numerical variables, you can choose the percentage or bar display. Pay attention that these displays are only dedicated to this view. In Transformation tab, it is possible to make some changes to columns. Changing the name, type, or order of columns are some of those changes. You can also deselect any column by unchecking its box. These options are useful when you are reading multiple files and want to have the union or intersection of them as a result. Such as columns, having some changes on rows is possible. Go to Advanced Setting tab, and define row limits or skip some rows. When you choose multiple files, this item will be activated. By unchecking, you let KNIME to read files with different specifications. Checking this box also supports reading file even with schema changes such as different column types.
Now, let's see how we can read spreadsheet files. Excel files can be read by Excel Reader node in KNIME. As default, the first sheet of Excel file will be read by this node. However, you can select any other sheet to be read by specifying its name or index. In these parts you can state if the Excel file has header and row IDs. Sheet area gives you this opportunity to read the whole sheet or select specific columns and rows. Transformation tab is similar to previous node, and in Advanced Setting tab, you can define some more reading options. For instance, what should be done while reading empty or hidden rows. If your Excel file is encrypted, you can type the password in Encryption tab in dedicated box.
CSV Reader node is another type of reader nodes. It is used for transferring data from text files like CSVs that contain data separated by commas. Going to Configuration window, you can see that the tabs are almost similar to previous reader nodes. In Reader option part, the delimiters can be specified based on the format of the text file. Checking these two boxes let you determine if the file has header or row ID column or not. Transformation and Limit Row tabs help you to filter or make some changes to columns and rows. In Encoding tab, you can select encoding type.
Next is File Reader node. It reads the most common text files. As you see, its configuration display is almost the same as CSV Reader node and offer the same options for reading a file.
In this video we intended to familiarize you with data categories and different ways of having access to data in KNIME. In next video, we will discuss some other ways of getting data into KNIME like generating data, and will review the output result of reader nodes. Until we meet again, just keep KNIMing.